17th one. Find the relationship between a and b if f of x equal to that is continuous at x equal to 3. So given that function is continuous at x equal to 3. So what we can write by the definition of continuity, limit x tends to 3 f of x equal to f of 3. So given that function is continuous at x equal to 3, therefore we can write limit x tends to 3 f of x equal to f of 3. Now when we find limit x tends to 3, we have to find left and right limits. When x less than 3, x greater than 3. See the function x less than 3, this value, x greater than 3, this function, this value. Therefore different. So we have to consider left and right limits. So we can find limit x tends to 3 minus f of x equal to limit x tends to 3 minus x less than 3. 3 minus means x less than 3. When x less than 3, what is the function? X less than 3, ax plus 1. Ax plus 1. When we apply the limit, what we get? In the place of x, we have to put 3. So 3a plus 1. 3a plus 1. Then we can find right limit. Limit x tends to 3 plus f of x equal to limit x tends to 3 plus. When x is greater than 3, 3 plus means x is greater than 3. When x is greater than 3, what is the function? Bx plus 3. Bx plus 3. Now we can apply the limit, put x equal to 3. So x equal to 3 means 3b plus 3. 3b plus 3. 3b plus 3. Now what is f of 3? F of 3. F of 3 equal to, when x equal to 3, that is 3a plus 1. That is also 3a plus 1. So since given that function is continuous at x equal to 3, we can equate these three. These three are equal. So 3a plus 1. So here these two are same. So we can equate these three numbers. 3a plus 1, 3b plus 3, 3a plus 1. So these are equal. So we can, here both two are same. So we can equate and we can find the value of, find the relationship between a and b. So we got, here we got 3a plus 1 equal to, these are same. So we can equate that to 3b plus 3. 3b plus 3. So now using that we can find the relationship between a and b. So 3a minus 3b equal to 2. So 3a plus 1, 3b plus 3. So 3a minus 3b equal to 3 minus 1. That is 3 into a minus b equal to 2. Therefore a minus b equal to 2 by 3. So a equal to 2 by 3 plus b. So that is the relation between a and b. Question is find the relationship between a and b if the function is continuous at x equal to 3. So using the definition of continuity, we found the relation between a and b. Now see question number 18. For what value of lambda this function is continuous at x equal to 0? We have to find the value of lambda for which the function is continuous at x equal to 0. So we have to, given that means if x equal to 0, if the function is continuous at x equal to 0, if f is continuous at x equal to 0, we know limit x tends to 0 f of x equal to f of 0. That is the definition of continuity at x equal to 0. Now we want to find these left side and right side. So left side, when we want to find the limit, we have to think whether we need left and right limits. X tends to 0. That means when x less than 0, x greater than 0. See, when x less than 0, one value, x greater than 0, other value. So we have to find both left and right limits. So limit x tends to 0 minus f of x equal to limit x tends to 0 minus. X less than 0, what is f of x? X less than 0, f of x. Lambda into x square minus 2x. That is, put x equal to 0. 0 minus 0. 0 into lambda. Lambda is some number, some constant. So 0 into any number. That is equal to 0. Now limit x tends to 0 plus f of x equal to limit x tends to 0 plus. What is f of x when x greater than 0? X greater than 0, 4x plus 1. 4x plus 1. Now apply the limit, put x equal to 0. So 4 into 0 plus 1, that is equal to 1. So we got this left limit equal to 0, right limit equal to 1. Now what is f of 0? f of 0 is also equal to when x equal to 0. When x equal to 0, 0 minus 0 into lambda 0. So this is also equal to 0. So we are given that if the function is continuous, left limit, right limit and f of 0, these three will be equal. But see here, 0 and 1, they will never be equal. 0 and 1 cannot be equal. Whatever be the value of lambda, 0 and 1 are not equal. That means what? This function is never continuous for any value of lambda. That means, therefore, question is, for what value of lambda function is continuous at x equal to 0? So for no value of lambda, function is continuous at x equal to 0. Therefore, 0 is not equal to 1. Therefore, you have to write sentence. Therefore, for no value of lambda, function is continuous at x equal to 0. For no value of lambda, function is continuous at x equal to 0. Now we have to consider, they have asked about x equal to 1. What about the continuity at x equal to 1? So we have to check the continuity at x equal to 1. If the function is continuous at x equal to 1, what is the value of lambda? That is what we want to find. So we have to consider x equal to 1. If f is continuous at x equal to 1, what will happen? Or to find the continuity at x equal to 1, we have to find we have to check the for what value of lambda function is continuous at x equal to 1. That is what we want to find. So limit x tends to 1, f of x we want to find, and f of 1. If this is equal to f of 1, we can say the function is continuous. So which value of lambda they are equal, that is what we are going to find. So to find x tends to 1 f of x, do we need left limit and right limit? X less than 1, x greater than 1. Is it continuous? Is it different? See, 1 is a number greater than 0. So x less than 1, x greater than 1 doesn't make any difference because very close to 1. So these both belong to x greater than 0. So no need of finding left and right limits, we can directly find the limit. Limit x tends to 1, f of x equal to limit x tends to 1. What is f of x when x tends to 1? X is very near to 1. That means x greater than 0. When x greater than 0, what is the value of the function? 4x plus 1. So now we have to apply the limit. When we apply the limit, 4 into 1, 4 plus 1, 5. And what is f of 1? F of 1 equal to, f of 1 means the value of the function when x equal to 1. When x equal to 1, x equal to 1 means x greater than 0. X greater than 0, f of x is 4x plus 1 and x equal to 1. So 4 into 1 plus 1, that is equal to 5. So both are equal. So it doesn't depend upon lambda. Whatever be the value of lambda, this left limit, not left limit, this limit x tends to 1, f of x equal to f of 1 for all value of lambda. Whatever be the, does not depend upon lambda. That means for all value of lambda, they are equal. Therefore, for all values of lambda, f is continuous. F is continuous at x equal to 1. So for all values of lambda, function is continuous because it is always equal. 5 equal to 5 doesn't depend upon lambda. For all values of lambda, 5 equal to 5. That means f is continuous at x equal to 1 for all values of lambda. Okay, then 19th. We have to show that g of x equal to x minus this is discontinuous at all integral points. So integral points, we have found out this is greatest integer function. We have checked the continuity of the greatest integer function and we have seen that it is discontinuous at all integral points. Here the function is given as g of x equal to x minus. Here the function g of x equal to x minus greatest integer function x. We have to check the continuity at we have to prove that it is discontinuous at all integral points. Integral point, so let C be any integer. Integral point means integer. Let C be any integer. Then we can check the continuity when x tends to. We know when at integer x less than c, x greater than c, the greatest integer function value is different. We have seen. So here also we have to find that is different. Therefore we have to find left and right limits. Limit x tends to c minus f f of x equal to, not f of x, here g of x. Function is given as g of x. So what, when x tends to c minus, what is limit of the function? C minus means x less than c. C is some integer, x less than that integer, so less than c means what will be the value of x? X we can write c itself, minus what is the greatest integer function? C. When x tends to c minus means x less than c. X less than c, what is the greatest integer function value? We have seen that in the example. So we get that is c minus 1. When x less than c, the value of that greatest integer function is c minus 1. That is, opening the bracket, we get 1, c minus c plus 1. And what is limit x tends to c plus g of x? When it is c plus, this x becomes c itself minus what is greatest integer function value? That is c itself. When it is greater than c, greater than that integer, just greater than the integer, the greatest integer function value is c itself. So we get 0. So left limit not equal to right limit, therefore it is not continuous at the integral values of the function. Okay.